Hi, Tim Iqr here. In this video, I'm going to create a Python program that tells you if you have outliers in your data set. Okay, so a little bit about outliers. Let's do a little draw island here. Okay, and basically what you need to know for outliers is that we have this rule, which is basically the 1.5 rule, 1.5 IQR rule, which basically is that 1.5 times the IQR, the interquartile range, if that is at least 1.5 times the interquartile range above quartile 3 or below quartile 1, then it's considered an outlier. Okay, and I have a previous video in the description on how to find the interquartile range, and I'll go into that a little bit in this one as well. What we're going to do in this video is we're going to create a class in Python, and then we're going to use methods from that class with an object to find the lower median, the upper median. So the lower median, I'll explain that in a little bit, is quartile 1. The upper median is quartile 3. The interquartile range, which is the difference between Q3 and Q1, and then the number of outliers we have. Okay, so anyways, I'm going to open Emacs, but first, if you like videos like this, please like, subscribe, and hit the bell for notifications, as it really helps the channel grow. And if you've done that already, thank you, and I hope you keep watching. Okay, so I've got a file open in Emacs, and I'm calling this outliers _yt.py. Now, this is a little bit complex, so I may look at some of my notes during this process. I'll also include in the description the link to the GitHub file that has this code in it on my GitHub account. Anyways, all right, so I'm going to just make the font a little bit larger. Okay, and there we go. All right, so let's get started. Okay, so what we're going to do is we're first going to import the math module, and then we're going to create a class, and we'll call that outliers. Okay, and we're going to instantiate the class, and so I'm going to pass in self, and then a data list. Okay, and we're not going to take the data list from the user. I did that with my interquartile range video, but in this one, we're just going to figure out the various different components: the lower median, the upper median, the interquartile range, and the number of outliers. Okay, so all right, so that's our. Oh, sorry, there we go. We're going to say self.data_list equals data_list. Okay, now we're done with that method. And now we're going to create another one called lower median. And we're going to pass in self. And we're going to have something called a lower median index. And that's going to equal, we have to make it an integer for an index value. Because the data list is going to be a list, and we have to give the index of the number that we want for quartile 1, which is the lower median. Okay, so we're going to use math.floor, and we're going to then pass into math.floor, pass the length of the data list divided by 4. Okay, so what math.floor is, it rounds the number down. Okay, and then we're going to say if math.floor of the length of the data list, if that divided by 2, and then if that value divided by 2, and then take the divided by 2 again, so we're going to use the modulo operator, if that equals 0, so no remainders. So Then what we're going to need to do is we're going to say that the lower median is equal to the data list with the lower median index plus the data list with the lower median index minus 1. Okay, so let's think about why that is. So I'm going to go out here and we'll just create a list of 9 numbers. So like 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 numbers, right? Okay, so if we take those 9 numbers, the data is split. This is the median, 5. It's right in the middle, right, when they're in order, okay? So what we need to do is we need to find the median of the lower half, which is the lower median. So that's going to be 2 plus 3. And then we're going to divide that by 2. So we're going to take this whole thing and divide by 2 to get the average. So it would be 2.5 in this particular case. Now, what we need to think about is what are the index for each of these. So really the index is 0 base. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So for 9 numbers, we have 0 to 8 as our indices. So we're really going to averaging indice 1 and indice 2. Okay. So if we take the length of this data list, which is 9 values, and divide that by 2, that we get 4.5. But we use math.floor, we get 4. We take that number, if that number is divisible by 2, so 4 is divisible by 2, that equals 0, then we have to take, we have to say the lower median index would be 9 divided by 4, which is 2.25, so it would be 2, right? So we take index 2 plus index 2 minus 1, so index 1. So we average these two values, which would be 2 plus 3, which would give you 2.5. Okay, so that's why we're doing it in that particular case. Okay. Else, I hope that's clear. If it's not, go back and watch my explanation again, and I think you'll get it. Okay, so otherwise, we're going to say the lower median is just the data list with the lower median index passed into it. Okay. All right. And so at the end of this, well, we want to now return the lower median. Okay, so we're out of that that method. Okay, the lower median is quartile 1. Okay, now we want to find quartile 3. So that's going to be the upper median. And we're going to pass in the self into this method. And for the upper median, it's a little bit different. Okay. And while I get too far ahead, let me explain why the lower median, when it's not divisible by 2, why it is this. Okay. So let's think about this. Okay. So if we have 7 numbers and we divide 7 by 4, so let's do a list of 7 before I get too far ahead into the upper median. List of 7. So 1, 2, 3, 4, 5, 6, 7 with indices 0, 1, 2, 3, 4, 5, and 6. Okay, in this case, the list is split at 3, right? And then if we divide 7 by 4, well, first off, if we divide 7 by 2, we get 3. 3 divided by 2 is not going to give us a remainder of 0. That's going to be, that's not divisible by 2. So in that case, we just use the lower median index, which is math.floor of 7 divided by 4. So 7 divided by 4 is 1.75. We bring that down to 1. It's index 1. So we see to find the list, well, index 1 is here. So we take this out, the lower half, the upper half, quartile 1, and quartile 3. Okay, so we'll think about that as we're coming up with our lists. Now, for the upper median, if we have this list of 9 again, we're going to have to check a little bit differently. So bear with me on this. So I'm going to first start by checking if math.floor of the length of the data list is divided by 2. If that, again, divided by 2, has a remainder of 0, okay, then what we're going to say is the upper median index equals the integer value of, in this case, math.ceil. And we'll get to that in a second, of length of the data list. So math.ceil rounds up times 0.75. Okay? All right. And then we're going to average two things. We're going to say the upper median equals the data list at the upper median index plus, move this up here, plus the data list at the upper median index minus 1 divided by 2. Okay, so let's take a look at our example from 1 to 9. So if we divide 9 by 2, we get 4.5. Math.floor, that brings it down to 4. Divide 4 by 2, that would lead a remainder of 0. So then we're having to say, well, the upper median is math.ceil. So 9 times 0.75, that's going to be 6.75. And we're going to need to round that up to 7, because when we split this list, we take out the middle number, then the upper list is going to be the second to last value plus the third to last value. So if we're at 6.75 for our index, we need to round it up to 7, but we also need to average it with the 6th index. So we have to average the 7 and this 8. Okay. All right. Else, what we're going to say is that the upper median index equals the integer value of math.floor, the length of the data list times 0.75, and then the upper median, the upper median is going to equal the data list evaluated the upper median index. Okay, and then at the end of this function, we're going to return the upper median. Okay. So now we've got the interquartile range, and we're going to use these two methods that are already in the class to find the interquartile range. So we're going to have a function called interquartile range. We're going to pass in self, and I'm going to make a variable interquartile range, IQ range, equals self dot, now we have to name the methods, upper median minus self dot lower median. Okay, and you need the open and close parentheses for the functions, but we are only passing in the self here, so you don't need to pass any parameters into there. Okay, and then we're just going to return the interquartile range variable. Okay, so that function is done. And now we have to have a function to determine outliers. Okay, so again, we're going to pass in self, and we're going to say outlier, which is an account for the number of outliers, is going to start with 0. And we're going to have to define two other variables. We're going to say upper outlier value equals self dot upper median plus 1.5 times self dot interquartile range. Okay, and then the lower outlier value is going to equal self dot lower median minus 1.5 times self dot interquartile range. Okay, so now we're going to have a for loop. We're going to loop through the data list. So we're going to say for data in self dot data list. And a couple of these, I need to fix this up. This needs to be self dot data list. Okay, I need to be using self here a lot, so sorry about that. Okay, let's move this around. Just clean this up a little bit. Okay. Hopefully I got all of them. If we're not, we'll just get probably a little error or something. And okay, so for data in self.data list, if data, so if the value is greater than or equal to upper outlier value, or data is less than or equal to lower outlier value, then we're going to add 1 to the outlier amount. So plus equals 1, and at the end, we're going to return the outlier. Okay. All right, so let's get rid of some of these lines. Okay, so what we're going to do now is we are going to create a data list that is already sorted. Now, this is important. You need to have your data sorted. Now, this is a data list I took off math.fun, mathisfun.com. You'll see the link to that video for the interquartile range in the description if you want to watch that. You probably want to watch that one first. So we go 2, 4, 4, 5, 6, 7, and 8 is going to be our first data list. And in this case, we should have no outliers. And we, let's see. So we have 7 numbers. So we're going to take out the 5. The quartile 1 is going to be 4, the lower median, and quartile 2 or quartile 3 is going to be 7. The interquartile range will be 7 minus 4, so it should be 3. And again, we'll have 0 outliers. And so now we are going to create an object. We're going to say the data set equals, you can name it whatever you want, equals the outliers class with the data list passed into that. And then we're going to print some things. So we're going to print the data set using the lower median method. So that'll give me the lower median. We're going to print the data set with the upper median method. Okay. We are going to print the data set with the interquartile range. And we are going to print the data set with the outliers. Okay. All right. So I'm going to save that. And let's open up another window. Let's go over there and open a terminal. And now to run the program, we're going to do Python 3, and then we're going to type the name of the program. So it's outliers _YT for YouTube.py. And we'll see that we get our values. So we get lower median is 4, upper median 7, interquartile range is 7 minus 4, which is 3, and there are 0 outliers. Okay, cool. Let's exit that process and go back to this window. And we're going to go, and I'm just going to comment out that line. And then I'm going to, whoops, not going to comment out that line, sorry. I am going to comment out this line. And then we're going to create another data list. So the second one, again, we're going to do this in order. If you wanted to sort the data list, if it wasn't sorted, just give you an idea of how to do that. You do data _list.sort, okay, and that would resort it. But this is just more demonstrating how you would come up with a class and methods to determine the interquartile range. Okay, so we're going to assume it's sorted already at this point. So we have 1, 3, 3, 4, 5, 6, 6, 7, 8, 8. And this is from that Math is Fun video that's, well, it wasn't about Math is Fun. I was using Math is Fun in the video. It's linked in the description. Check it out. Anyways, so this is the second list they had. This has 10 items in it. So we'd split it right down the center here. Lower list would be the middle value here, 3. The upper list would be 7 again. So we're going to get 7 again. So we should get 3 and 7 again with an interquartile range of 4 again. And then we're going to do a little bit different list. Okay, so we're going to run this program again, and we get the same values for the different list. Okay, not that interesting. But now we're going to start to go into some different lists. So I'm commenting this one out, and then we're creating a new data list. And this time, data list is going to be a little bit different. So this time, I'm just going 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have 9 values in the data list. So we're going to take this middle one, 5. The lower list is 1 through 4. The upper list is 6 through 9. Lower quartile should be 2.5. So quartile 1 should be 2.5. Upper 1 should be 7.5. Interquartile range should be 5 with 0 outliers again. Okay. So I'm going to save this and then, wait, sorry. Okay, and I think it's saved. All right. Anyway, so we're going to go to the other window over here, open up a terminal. All right. Clear this stuff out, and then let's run the program again and see. So now we get 2.5 is the lower quartile, quartile 1, 7.5 is a higher quartile, interquartile range is 5. We have 0 outliers. Cool. Okay. Now I'm going to comment this line out, and now we're going to create one with an outlier in it. So this time we're going to do a data list, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we're going to make an outlier of 20. Okay, that's going to be our outlier. Okay, we're saving that file and then going over here and running another terminal, clear this out. And now you see, okay, so now let's go through this. So we have 1, 2, 3, 4, numbers through 11 and then 20. So we have 12 values in the list. So we'd split it 6 and 6, and then we'd average 3 and 4 for the lower quartile to get 3.5, and we average 9 and 10 for the higher quartile to get 9.5. So 9.5 minus 3.5 gives us the interquartile range of 6, and then we have one outlier. Okay, that's above that outlier value that we programmed in earlier. Anyways, I'll give a link to this program on GitHub. And then you can check it out and play with it some more. There may be some edge cases that I haven't thought of that I may need to fix the programming on. If you find one of those, I'll leave a comment in the comments below. Otherwise, I think this was a good look at objects and classes and objects in Python, and methods, and passing a method from a class into another method in the same class, and also a fun look at statistics. I hope you found it useful. Again, if you did, please like, subscribe, and hit the bell for notifications, as it really helps the channel grow. And if you've already done that, I hope to see you in the next one. Thanks for watching.